All right, we have another question on the board. We are still looking at the concept of friction. We are still considering the concept of friction. Okay, so we are still considering the concept of friction, and then the question says an object of mass 15 kilograms is at the point of sliding down a plane inclined at 36 degrees to the horizontal. Find the least force parallel to the plane required to make the object to begin to move up the plane. So we are told that the object of mass 15 kg is at the point of sliding down a plane inclined. Now, that is an inclined plane. You will draw your inclined plane. First, you have a diagonal line that is placed on a horizontal surface. Okay, you have a diagonal line placed on a horizontal surface. Okay, and you place the block. Place this block. Okay, and then the plane is inclined at an angle of 36 degrees. An angle of 36 degrees to the horizontal surface. Okay, now you look for the weight. The weight of this block is acting vertically downwards. The weight acting vertically downwards is equals to mg, which is equals to the mass is 15 kg. That is 15 kilogram multiplied by g is 10 meters per second square. So 15 times 10 will give you 150. Okay, so we have 150 Newton. So the weight is acting vertically downwards, and you have W equals to mg. The mass is 15 kilogram and g is 10 meters per second square. If I multiply it, I have 15 times 10, which is 150 Newton. Okay, and the next thing you take there is the you take a normal reaction acting at 90 degrees. 90 degrees to this surface is the normal reaction. You see, that's a perpendicular line. This is the surface. This is the surface. And at 90 degrees to this surface is this. You take a perpendicular line. You call this your normal reaction. Okay. So if this is 36 degrees, the angle here as well is 36 degrees. I believe they are in the same segment. This is angles in the same segment. I'll resolve this force this way. Resolving this force this way, I'll be having we'll be having something like this. This is W cos 36 degrees. And remember, we solved our W and we had W as 150. So this is 150 cos 30. So resolving this 150 Newton force perpendicular to the plane, I have 150 cos 36, and resolve it parallel to the plane. Parallel to this plane, I'll be having 150 sine 36 degrees. So I'm having 150 sine 36 degrees. So I resolve the force perpendicular to the plane, resolve it perpendicular to the plane. I have 150 cos 36 degrees. I resolve it parallel to this plane. Parallel to the plane, I have 150 sine 36 degrees. 150 sine 36 degrees. So parallel to the plane is this, and perpendicular to the plane is this, 150 cos 36. Alright, okay. Now the next thing we look at, we are told that it says find the least force parallel to the plane required to make the object to begin to move up the plane. To make this object move up the plane, there is a force that is acting parallel to this plane. Okay, we can call that force, we can call it an effort E. Okay, so an effort was applied here, which was pulling this block upwards. Okay, it's pulling the block upwards. It's showing you the direction of motion. Impending motion is up the plane. So impending motion is up the plane. That means frictional force will act downwards. Frictional force will act down the plane. Okay, frictional force will act down the plane. We call this F. And frictional force is equals to coefficient of friction times the normal reaction. Okay, so my frictional force is acting down the plane. And like I told you, the friction force must occur between two surfaces in contact. What are the surfaces? That is the bottom of this block, the bottom side of the block, and then this inclined surface. So it is between the inclined surface and the lower part, the bottom part of the block. I will have my friction force F. Okay, friction force now, the coefficient of friction times the normal reaction. Okay, so we are asked to find the least force parallel to the plane required to make the object to move up the plane. Right, so we'll do that quickly. And then we'll say, okay, do that quickly. We'll say, first we'll take this one. You say the upward perpendicular force be equal to the downward perpendicular force Right, so the upward perpendicular force equals to downward perpendicular force, and the upper perpendicular force there is the normal reaction arrow equal to the downward perpendicular force is 150 cos 36. So look at this closely. This is our upward perpendicular force arrow, and the downward perpendicular force is 150 cos 36. 150 cos 36. Okay, so arrow will be equal to, if you look at your calculator, cos 36 will give us cos 36. So if I find cos 36, it gives me 0.809, and if I multiply it, I'm having arrow as 121.35. That's my normal reaction. So my normal reaction is 121.35. So cos 36 gave me 0.809. Okay, and when I multiplied it to 150, I had 121.35 Newton. It's 121.35 Newton. Okay, now the next thing I will take is the upward parallel forces equal to the downward parallel forces. I say upward parallel forces equal to downward parallel forces. Okay, so the upward parallel force there is force E, and the downward parallel forces, you have 150 sin 36 plus F, that is 150 sin 36 plus the friction force F. Okay, and the friction force F there is mu arrow, as friction force is coefficient of friction times normal reaction. So this is 150 sin 36 plus mu arrow. Okay, all right, so we'll look for sin 36. So sin 36 is 0.588. Okay, 0.588. Okay, plus the coefficient of friction is unknown. We'll suspend that, and the normal reaction, we had the normal reaction as 121.35. 121.35 Newton. Okay, so if I multiply this now, okay, so 150 times this gives us 88.2, plus this times this will be 121.35 mu. Okay, which I can call this equation 1. Okay, so the effort applied there is this, call it equation 1, suspend that. Then you say but the coefficient of friction is equals to tan theta. Yes, coefficient of friction is tan of the angle of inclination, that is the tangent of this angle of inclination. So you say mu is equals to tan, we had theta as 36 degrees. The angle of inclination here is 36 degrees. So that is tan 36 degrees. Tan 36 will give us 0.73 to 2 decimal places. If you check your calculator, approximating it to 2 decimal places, That is 0.73. Now I've put it back into equation 1. Put back into equation 1, you say, so therefore E equals to 88.2 plus 121.35 multiplied by 0.73. Okay, so 121.35 multiplied by 0.73, that will be, okay, so 121.35 times 0.73 will give us 88.59. Then add it to 88.2. Add this to 88.2 with your calculator. What will you get? So if you add this now, you'll be having 176.79 Newton. Okay. Alright, so if you add them, you'll be having 176.79 Newton. So this is the force that makes this block to move upwards or to move up the plane. Alright, the force that makes the block move up the plane is this. Okay, they said find the least force parallel to the plane required to make the object to begin to move up the plane. This is the force E. We have solved that using Newton's third law of motion. So the upward parallel force will be equal to the downward parallel forces. So the upward parallel force here is E. The downward parallel forces are 150 sin 36 plus the frictional force F. So that is what we just did. A frictional force is the coefficient of friction times the normal reaction. The coefficient of friction was unknown. The normal reaction, we solved the normal reaction and we had 121. We had 121.35. We had 121.35 Newton. Okay. Alright, so that's what we substituted here. In place of arrow, we substituted it. Then mu, coefficient of friction, which is mu times 121.25. If you multiply it, you have 121.35 mu. Now we call that equation 1. Why? Because mu is unknown. Now we solved for the value of mu. We solved for the value of mu. We say that mu is equals to tan theta. Okay. So we say that mu is equals to tan theta. Okay. Now we have the value of theta, the angle of inclination, as 36 degrees. Now if I put it there, substitute 36 degrees into this. Say the value of theta is 36 degrees. I substitute it here. So in place of theta, I write 36. So this will be tan 36 degrees. And tan 36 degrees is 0.73. Okay? Tan 36 is 0.73. Okay? Now I will then put it back into equation 1. Substituting this into equation 1, I'm having this now will change to 88.2 plus 121.35 times 0.73. Okay? That is this. So 121.35 times 0.73 gave me 88.59. Add it to 88.2, I'm having 176.79 Newton. That is the force we are asked to look for. Thank you very much. Thank you.